Hello everyone, this is the lesson where I'm going to show you how you do the proof of the sine rule. Before we do that, let's look at the sine rule. The sine rule says sine A, which is an angle, over A, which is a side, is equals to sine B over B is equals to sine C over C. Or you can have the sides on top. A over sine A is equals to B, which is the side over sine B, and then C over sine C. Okay, now when do you use the sine rule? It's when you don't have a right angle. You have a triangle and it's not a right angle triangle. So you use a sine rule to find a side or an angle. So now, how do we find this small letter sides? The side that is opposite that angle, this angle is angle A. The side that is opposite angle A is called A, it's the small letter A. And then the side that is opposite angle C, this side that is opposite it is small c, and then this one will be small b. So it means the sine rule says sine of an angle divided by the side opposite to that angle is equals to sine of another angle divided by the side that is opposite to that angle when it's b divided by b. Now we don't use all three of them. They're just showing you that you can use this one or that one. That you use two at a time, but any two, you can use any two. You just need to have a side and an angle. A side and looking for another angle or for another side in the other side. But in this lesson, I'm not using the sine rule. I'm showing you the proof. So I'm going to show you the proof now. Okay, you're going to construct a height, h. Height is perpendicular, so you're going to have that as a construction, so it will be dotted line and then it's h. Because it's a height, it's 90 degrees to line AB. Now if you have a right angle triangle, then you can use trig ratios. You can use sine is opposite over hypotenuse because you have a right angle triangle. And in the original triangle that we had, you could not use that. It was not a right angle triangle. This will be a dotted line. In this triangle, in the bigger triangle ABC, now you have two smaller ones. We're going to use the two smaller ones. This whole line is line C, but we'll have a point here, which we call D. We'll have in triangle ADC. So it's this triangle. Then we have that angle, sine A is equals to opposite h over hypotenuse b. Then we solve for h. We multiply b here. We'll have b sine A is equals to h. This will be our equation 1. Now we're using the other triangle, this triangle CDB. In triangle CDB, here's our angle. So we'll have sine B is equals to opposite is our h over hypotenuse for this triangle is A. So also we solve for h here. We'll have A sine B is equals to h. This will be our equation 2. Then we equate. We say equation 1 equals to equation 2. What would you have? B sine A is equals to A sine B. Why can you do that? Why can you equate them? Because you see they are both equal to the same thing. A sine B is equals to h and B sine A is equals to h. So because they are equal to the same thing, you can equate them. It basically means they are equal. So here, what you do on your left, you do on your right. You divide by line AB both sides. Then the B will cancel the B. I'll be left with sine A over A is equals to this side. The A will cancel the A. Then I'll have sine B over B. This is how you prove the sine rule. You see sine angle over the opposite side is equals to sine angle over the opposite side. This is exactly what we had there at the beginning. So we have proven the sine rule. This is the end of our lesson. Thank you for watching.